Alright guys, so today we're going to talk about simplifying expressions with rational exponents. So let's look at our first page right here. So we already know that a squared power right here, oh you can't see that, a squared power right here cancels out a square root, and you're going to end up getting an answer of x plus 2. So we already know that, but we may not be completely sure as to how a squared power cancels a square root. So let's look at that. So first we need to look at our notation here. So let's make note that the b right here, this big number right here, that is our base. And then with our rational exponent right there, the top number, the numerator, that is our power. And then right here on the bottom, the denominator, that is our root. That's why in our title it says power over root. So there you go. And a neat little trick to remember this that we have right here is a little saying where power lines are above ground and then roots of trees are below ground. So if you're a more visual person, you can imagine that our dividing line right here and our rational exponent could be the ground, and then the p is like our quote power lines that are above the ground, and then our r in the denominator are quote the roots of the trees. So that's a little trick if you need help remembering that. Alright, now we're going to look at our first example, which is 7 to the half power. So first we need to identify what is our power in this expression. So look over here, and the power would be our top number, which in this case is 1. And now we need to look at the bottom number, and that would be our root. So in this case, our root is 2. Now we need you to convert it into a square root form. So in that case, we have our 7, our base, and so our root would literally be a square root to the second power. And then for our power, I apologize, I misspoke. So what we have here is a power of 1, and then our expression over here has a root of 2. Alright, let's look at another example. So this one we have 16 to the half power. So we look at it, our base over here, that's 16. And then our power, so let's identify the power. It's always going to be our top number right there. In this case, our power is 1, yet again. And our root, this bottom number, our root is equal to 2. So, going back over here, we write that our expression, the 16, has a root of 2, square root, and a power of 1. Though the power here would be a little redundant now, wouldn't it? So it would be equal to square root of 16. Now, square root of 16, that's a perfect square, so we can evaluate this even further. So our final answer for this example is going to be 4. All right, one last example just for good measure. So once again, let's identify our power and our root. So in this case, the power, once again, that top number, that is going to be 1. And then our root, this bottom number, as always, is going to be 2, yet again. So now let's convert it into square root form. So we have 100 with a root of 2 to the power of 1. But of course, this will just be square root of 100 because anything raised to the first power is just itself. Now we can also evaluate this one, this expression. And so the square root of 100 will give us 10. So now we go back to our previous, like our first example. So based on the knowledge that we have just gained, we can see that you can rewrite a square root as anything raised to the half power, based on what we have seen over there. And then, since we have it to a half power, it's still raised to a second power. And then if we multiply our two exponents right here, that would give us it would give us 1. So that's how a second power cancels out a square root. All right. And the same principle would apply if this were third root raised to a third power. It'd be the exact same thing. So in this case, we would write it as x plus 3 to a third power raised to a third power. So once again, these two numbers multiplied together, they wouldn't cancel out, but they would equal 1. And that is what gives us the final answer of x plus 3.